Welcome everybody to the CoRE Conversations podcast. This is your monthly discussion on sustainable construction innovation, a platform for all construction professionals, all construction students, and I mean to anybody who really deeply cares about building innovatively. My name is Grace Bako. I'm gonna be your host, and today I'm joined by two professionals who are gonna introduce themselves in a few. Is on mass timber, and because I'm not the expert here, I'm not going to preempt anything, so we're just going to go right into it. I'm going to start with you.
So my name is George Wekesa. I'm an architect working with BuildX Studio. I'm very passionate about building materials and building techniques that actually help the environment. We've been pioneering this initiative about mass timber, but now we're here to just talk about a bit more about the conversation around it. I'll be a bit technical, but I'll try to keep it light, so that it's actually something that all of you can actually understand, and, and from here on you can adopt it.
Great.
My name is Wakina Mutembei. I run, or rather lead, the mass timber initiative at BuildX. We are focusing on cross-laminated timber as one of the materials from mass timber. I won't get much into that. I'm actually a trained quantity surveyor, so we should be able to have the discussions around mass timber with more specifically on cross-laminated timber. Thank you.
And she can advise us on the costs. Thank you for that, Wekesa. You're very key. So what is mass timber, and why should Kenyans care about mass timber construction, since you guys are pioneering this in Kenya? And I don't think many people know about it, so I think now with this out there, they'll know.
Yeah, so mass timber basically is comprised of the basic sawn timber that we know, but now layered together to form a much more superior product. So all large timber products that you see out there, you can be termed as mass timber. It doesn't exclude the sawn timber that we know, the traditional one. It just means that the sawn timber has been engineered to a level where it can actually perform equivalent or even better to steel and concrete and all the other traditional construction materials that are out there.
So mass timber is engineered timber.
Yes.
Yeah. So we've taken timber and engineered it. Into layers. So it forms bigger panels, isn't it? Yeah. All right. So with this, I know you guys have a project, isn't it?
Yes.
Yeah. Why did you decide mass timber? I mean, there's concrete, there's steel.
Yeah, the reason we're looking at mass timber is looking at the construction industry. It contributes to 40% of all the carbon emissions in the environment currently, which obviously is very questionable, because we have to get to a point where we're looking at climate change and having climate action to reduce the amount of greenhouse gases we're emitting into the environment. Yeah. Kenya being a country that is growing quite fast, and Nairobi specifically due to urbanization and due to the balance of houses provided and what is needed in the market currently, you can already foresee in the next few years there's going to be a rapid construction of houses. So that rapid construction of houses, how does it contribute to the greenhouse gases emissions within our country? Remember, as I said earlier, there's 40% of what is emitted by construction. Multiplying that to how much we have to do in the next few years, I mean, the numbers are insane. So what do we have to do to reduce that? Part of this 40%, we have 11% that is as a result of construction materials. And we have the balance between 40 and 11 as a result of how much energy do you need to run your house, what are you doing with your waste management, where are you getting your water, how are you managing your wastewater. So BuildX being a build, develop and design firm in a construction industry, we had to look at it from a point of construction, from a point of developing, which brings us to designing houses that actually address the 11%. Steel, concrete are the biggest emitters, because we have to burn a lot of fossil fuels to be able to create steel, to be able to create concrete. However, we have wood, which are trees. So trees by themselves are carbon stores. So how can we use the trees to build houses? It's very simple. Just lightly engineer the wood, as he talked about swan timber. How do you lightly engineer it to make it stronger and better than concrete and steel, and then use it in construction? By doing so, we're reducing 11% of carbon emissions in the world, multiplied by as many buildings as we build. And that's why BuildX is focusing on cross-laminated timber, because it consumes more wood, it is stronger than concrete and steel, and construction is faster, which I think we'll get to as we go along.
Exactly. I like the fact that you've really just listed down the properties that actually make it worthwhile for us to consider as Kenyans. But before this set, I know we talked about affordable housing and how affordable is affordable. Yeah. So how affordable is mass timber? I don't know if I should have asked the QS, but
I would say it's dependent on the journey we are on at the moment. So where we are at here in East Africa, we have to import our mass timber for the next foreseeable future. Great. To a point where we can actually set up our own producing factory here, and at that point we'll be very competitive compared to traditional building materials. So I would say, for a start, it's expensive because of the importation aspect, but once we've built enough demand, once we've advocated for it enough to have people actually wanting to buy it as a material, and set up a factory here with our partners, that will be the point where actually it will have that sweet spot of being very, very affordable.
I get that. And I love that you said that you're importing. A question I really wanted to ask you, like, where are you guys getting your trees? Do you want to get angry with Wangari, our ancestor? But what's the plan? What's the bigger plan with our trees? Yeah, we don't want to bring our ancestor back down here. You know how she feels about this thing. Yeah, what's the main deal? What's your plan for this?
As Wakesa said, at the moment we are not producing any mass timber locally, and that's where I come in at BuildX. Great. As I said earlier, I'm leading a mass timber initiative within East Africa, which is basically looking at the supply of mass timber from the tree to buildings and buildings and buildings. So what really has to be done to make this possible? As you said, we are looking at Kenya as a market where logging has been completely banned at the moment. Yeah. But we also are looking at a country where we don't have as much mass timber being produced. Actually, no mass timber is being produced.
Do you even have a factory?
We have factories that are drying trees, drying logs to make swan timber. Yeah. We have factories that are now starting to get funding and invest into grading for that. Yeah. And probably to back up a little bit, I'll explain how you're able to make mass timber from just a log. Yeah. So you're looking at something that has been planted and you have cut it off, and that is just a log. You've got to dry it, you've got to make it into swan timber, and most importantly, you have to grade it. Grading it in terms of the strength of it, the properties of that swan timber itself. Because to make mass timber, the grading has to be very specific, because that is what the strength of the building you're going to make depends on. Okay. So after grading, then it goes into a process whereby it can be finger bolted, which is the easier part of it. It can be glued and then made into cross-laminated timber. So in Kenya currently, the factories we have only go up to the point of, making swan timber. Actually grading, not yet. But we're looking at some organizations locally that are looking to fund local companies to get into now grading the timber, which I see as a very good step towards now making cross-laminated timber. So right now, for us to be able to do, because we already have a prototype made out of cross-laminated timber.
Well, exactly.
I mean, obviously, we had to import the cross-laminated timber, and it's more a situation of what comes first, what comes last. And how we see it being in the market we are in, we have to show people, hey, this is how it's going to look at. Yeah. Because no one wants to be a guinea pig. Yeah. And as BuildX, we have to be able to demonstrate that. So that's why we had to import the cross-laminated timber. However, we're working with the government, we're working with development agencies, we're working with local companies, within the construction professionals, within the forestry professionals, and also people who are looking at reducing the amount of carbon emitted in the environment to be able to set up a cross-laminated timber factory, either in Kenya, in Tanzania, or in Uganda. Now, when it comes to the source of the timber, we have Uganda for the last 20 years that has been doing a lot on creating sustainably grown commercial forests. So, with 20 years ago, they had probably 17,000 acres of sustainably grown forest, and now they have up to 100,000. Looking at the end of next year, we're expecting them to be producing approximately 400,000 tons of timber that they do not have a market for. But Kenya, being a country that is growing very fast, we have a very huge gap in the number of housing we have to provide. It creates a very lucrative opportunity for Uganda to export its timber to Kenya.
Over here.
Now, what hasn't been decided yet or hasn't happened yet is, are we going to have this cross-laminated timber factory in Kenya, Uganda, or Tanzania? That has not been decided yet. But we have Tanzania, a company called CPS, that is already building with cross-laminated timber.
Is it?
Yeah. And looking at the cost of using cross-laminated timber at the moment, it is definitely very expensive because you have to export, you have to import, But removing the cost of duties, the cost of transportation, the cost of all the other costs that are associated with landing it here, and comparing just cross-laminated timber as a product to concrete, to steel, I mean, it's very competitive. It is actually very compelling. And the other addition that makes it even cheaper is that when you use concrete and steel, I mean, the construction time is more. So if the construction time is more, you've got to pay more on labor.
Time is money.
For cross-laminated timber, it is produced in a computer-controlled environment. So Wekesa, as a designer, as an architect, is going to design specifically to how the building is going to be. The factory will produce exactly the panel that is needed. So when you go to site, you're cutting almost 70% of the time you could have used. Yeah. So cost-wise, in the short term, as Wekesa said, obviously, is going to be high. But we've got to show people how it could look like, how it could be done. And we have to bear the expensive cost at the beginning. But as we go ahead and this factory has been set up, the demand is going to be there, the cost is going to be lower.
Wow. She just convinced me. I think I'm just going to be one of your... I'm going to have my first project with you guys. But you've talked about really nice qualities, One thing we know about timber. Let me not say we know. As people out here, if they hear about timber, they'll be like, this is timber, this is weak, this is valuable, this is, fire prone. So what measures do you have in place, or how do you look at that as mass timber in, eradicating that sort of thought?
I think it requires a behavioral change, first of all. But just going back to the product itself, there are certain properties of it that haven't been fully understood about mass timber. So mass timber, in comparison to existing traditional building materials, is very predictable in terms of its behavior with fire.
Great.
So that, as a starting point, means that you are able to plan, predict, and mitigate against anything that comes along the way in case of a fire. But at the same time, the way the material burns, or the way the combustion happens with the mass timber products, I'd use an example of cross-laminated timber. So cross-laminated timber, how it's made is the panels or the sawn timber are joined at right angles and pressed together under high pressure. So it's more of a layered product. And as a structural engineer, you would design with just the core of it as the basic structural element, such that since its nature of burning is it chars on the outside and prevents the fire from spreading into the inner core, the inner structural core can actually maintain its integrity when a fire happens.
All right.
Long enough for it to actually be mitigated, for the fire to be put out, as opposed to a material like steel, which is very unpredictable, so you wouldn't really know what to expect out of it once a building was on fire, for example.
Yeah.
And the other aspect of it is people are normally skeptical about the height, you know.
How high can it go?
How high can it go?
Yeah. If it crumbles, you come down like a person who was on a ladder.
So it's basically as strong as any traditional building materials in terms of strength, or even better, because the whole element of engineering makes it such that it's easily if I go a bit technical,
great,
like the deflection of the members happen in a very organic way, I'd put it that way.
So guys, you have to go Google deflection so that you understand what Wekesa is saying. Yeah?
Such that for a building that's in an area which is prone to earthquakes, for example, you want the building to sort of roll with the earthquake and not really be stiff and brittle and break. So a CLT building, for example, would behave in that manner. It will kind of go with the flow of the earthquake, embrace it, and kind of more like a raft.
Okay.
And then, so in a sense, that saves the whole destruction that comes with earthquakes. So it's very resistant to earthquakes compared to other traditional building materials. Which means, like, even as people talk about fire, there are also other things that they don't know about that actually make it very superior, and which actually we should get more into. Yeah.
Yes, and I like that. And when you're saying that, I just thought, if you build a house with timber and then just someone comes with a saw, cuts it, without cutting your. Do you have like some sort of like the you talked about the prototype that you have, and I think it's in Tatu City, isn't it?
No, we're currently moving it to our offices in Loresha.
Great. So
beginning of August, you can call me. You should leave my number. You can call me, and then you can come see it. You can interact and get to know more about it.
Great. So the prototype that you have, is it just made of timber? Because I just want you to confirm, because the one I have in my head isn't made of timber. Like the panels exactly. It's just panels, and then there's a sort of cladding of masonry.
I can probably explain why it's the cladding.
Okay, someone that doesn't comment.
So
cut your house.
It's actually not for cutting. So we made the prototype for two reasons. One, we wanted to get the market perception of what mass timber is.
Yes.
The second aspect was more or less as an exhibition space. So besides us like getting input, we also showcasing it.
Yes.
So there's the element of discovery that we wanted to have with this element of the prototype. So we sequenced the exhibition such that you come in from a very familiarized atmosphere. You see all the finishes before you actually discover that this is made out of timber. So timber, like any other traditional material, can actually be cladded as well. But at the same time, you can actually leave it exposed because it has certain health benefits with just seeing that, the grains and all that. So that's why we had to, at the very place where you enter, you're familiarized. You don't even know what you're coming to get yourself into. So you're not biased in your feedback.
I see.
So that you actually see, you feel, and even touch the space before actually start commenting on certain biases that you would have had if you had come
just
straight to a timber building. So that's why we had the cladding.
How high can it go?
It depends.
We have the tallest building right now at 84.5 meters.
Okay. What's the foundation?
The foundation is mostly concrete.
Okay.
Yeah. We also have in Tanzania, in Dar es Salaam, we're looking at CPS doing a 94 meters high residential building.
Residential?
Yes.
Wait, do they have buyers? We need to confirm that. Maybe they just they do have buyers who are buying into this timber building.
Yes, and if for example, I cannot speak for the building in Tanzania, I do not have the authority to. However, looking at the one they have in Zanzibar, in Fumba town, the houses are being sold. They have a showroom in Sarit Center where you can go see and buy a house made out of cross-laminated timber. So yes,
wow,
they're selling.
I think the main point here is to convince someone that this is strong.
Yes.
Like timber is strong.
Yeah.
Timber is strong, timber is scalable, timber is fast, timber is circular. There's so many ways.
It's good for your health.
It's good for your health.
It's good for our environment.
Did you hear that?
Good for the environment. There's so many things we can put to timber.
And it's strong. I just need to be convinced that timber is
It is versatile and strong.
And to add to that, as BuildX, we're currently running a project where we want to build a cross-laminated timber tower. But before we get there, we have to work with professionals who have done this before.
Yes.
So we are in the process of hiring professionals in all the engineering disciplines. And also...
Is that a job advert people should be keen on?
Yes.
If you know anything about timber, you can apply.
So we're working with fire, civil, structural, environmental, acoustics, in architectural capacity building, to be able to put together a technical paper that anybody with technical questions can be able to look at and understand from people who have actually built the buildings I'm telling you about in Europe, in North America, and now they're coming to look at how we can do it within the tropics in Kenya. And this is the basis of how we're going to do the cross-laminated timber tower with such expertise so that we can actually build something that won't crumble down like a ladder, something that if there is fire, we're able to deal with it up front, something that you're not going to come and cut with,
That one.
So crane to cut to
so we're approaching it very technically with people who have experience of more than 5 years of doing this to be able to advise us. And beyond advising us, they're transferring their knowledge to the team at BuildX, the technical team, the architects, the QSs, the engineers, to be able to do this in future.
They're transferring the knowledge to BuildX. BuildX is Kenya. So that's, an improvement.
And then from there we can start transferring the knowledge at university.
Exactly,
and the tower will be there. You would see it.
You will not be able to cross that.
And our aim is really not to just build a cross-laminated tower, but to help the Kenyan professionals appreciate it, understand it, take it on. We don't want to be the only ones doing this. We want to start and catalyze the rest of us to believe in it.
Because yours, I know it's business, but you're looking at it wholesomely in a manner to support other construction firms. So we have talked about the different properties, and still really for people to understand, there's one property I want to talk about and how it reacts to weather, how it responds, let me not say reacts, how it responds to weather conditions. Has that been tested? I know we don't have freeze and thaw, we're not on snow, but because it does well in like snow areas. But now in Kenya, there's a lot of rain, there's a lot of wind. How does cross-laminated timber respond to those
so first of all, the timber that you use for the cross-laminated panels or any other mass timber product has to first be specific for the region. So we wouldn't use a product here that's actually that works well in a different context, or in terms of even our forestry supply. That's also something that we have to think through. As you mentioned about Uganda, Tanzania, them having already taken this initiative. Starting with what you have that does well in your climate, that's a good starting point. The next thing is, so once now it's been engineered, there's a testing process that has to go into that, which actually is more or less even what we as experts here, we're trying to gain more knowledge from like much more experienced people of how actually to translate something that's done elsewhere here, and what are the parameters that need to be shifted for this to actually happen. So it's very doable. It's not a bias towards like the cold climates. Yes, they've pioneered like some of the very tall buildings, but we are here to learn from them. Yeah.
So what you've convinced me that I won't have my house and I'll be rained on, or is that?
No, and it has the same. I would say life cycle and even better because it's circular. Okay. As a traditional building. A traditional building, at most, or at least we give it 50 years before any major maintenance work can be done.
I see.
So with mass timber, it goes beyond that. It's circular, meaning you can actually design for disassembly, or even if you do not design for disassembly, the products that, or the sort of what you could call waste can be repurposed into another product and goes back into the whole system. Or the fact that it's actually biodegradable can actually just go back into the soil and nurture other trees, and the cycle continues.
I love the whole concept of sustainability and how it's versatile, in all aspects, but you talked about cost. Yeah, and you said, after some time, this will be, once we have our factories here and we can manufacture and all that, the panels, But now, besides you guys did, you're getting it from I was gonna say abroad, and this is just a side joke. Someone told me that Kenya is abroad, so someone in Uganda said Kenya is abroad, and I said, wow.
So we're getting
yes, you're getting it. You're getting it from abroad, So, has it been introduced on the other side, and how are they looking at it?
The other side, you mean in terms of
in Uganda?
In Uganda, to speak in terms of costs, the cost of cross-laminated timber, specifically as a part of mass timber, is expensive for two reasons.
Yes.
One, the cost of duties and customs.
Yeah.
Two, the cost of transportation. So now, do this mathematically. Cut off duties and taxes that you have to pay, cut off the transportation into, getting it from Austria or getting it from South Africa to something that is probably 2% of that. So obviously, that is much cheaper.
So confirm, you just get it from Tanzania and Uganda, you said?
Yes, and this would not be cross-laminated timber because the market currently does not show a huge demand of cross-laminated timber in Uganda. So it would be the transportation of a log into a log, exactly. Into a log into Tanzania, where there's a market for cross-laminated timber.
And now hopefully Kenya.
And hopefully Kenya. And then the panels can be made in these two. And then remember again, cross-laminated timber is not, it would be quite inefficient to just produce it as a material. However, it's more efficient. To produce it, hoping somebody will buy it.
Yeah.
However, it's better to produce it with a market in mind. I'll explain this.
Yeah.
Wakesa is working on the cross-laminated timber tower at BuildX. And he has designed to the dot of the walls, the floors, everything. And whatever is being produced within the factory is specifically to what he has designed. You get? So there is less wastage. It's more efficient, makes the cost lower. To add on to the fact about the strength of it, remember I spoke about grading of the timber being the most important and being the first step into making any mass timber. So before you get even to the end that you've produced it to test it, you already know its properties originally. You know how it's going to respond to humidity. You know how it's going to respond to rain. You know how it's going to respond to wind. And at the same time, we're working with professionals, experts, who've already done this in Europe, in North America, to bring in their experience and their knowledge to help us create a more predictable environment and to help us create factories that actually take care of every aspect that we should be looking at.
Wow, I'm actually vouching for you guys, man. And I said I'm gonna have my first project with you. But before we are coming to the end of our discussion, but I'd like us to talk about the one that you just mentioned that Wakesa is working on, the cross-laminated timber tower.
It's going to be called an XLT tower.
XLT tower. Talk about this. I'm going to call it a case study. It's still a case study, not a prototype now. Talk about that. And you definitely need developers for this, isn't it? Or you guys are the developers?
We are partnering.
You're partnering?
With other partners to sort of come up with
I was almost going to ask, how did they agree? How did they accept to? But anyway, you've convinced me already, so I understand you convinced them.
Yeah.
So talk about this just a little bit so that people know about it. What's its name? Where is it located? And what should we expect?
Okay. I think we're going a bit ahead of ourselves. So thing is, I worked on the first phase of the design project, which actually got us to this point. Okay. First of all. The XLT Tower is much more an initiative that Okina here is leading, that we would get into after we've sort of done all this coordination process, understanding the whole forestry value chain, going back into the conversation she mentioned about partners who are more experienced and all that. So in that sense, we're more or less coming in as a partner to gain the knowledge and even find a way in which we can advocate for it and build the demand along the way. Back to the design project. So design project I worked on was called Module. So MODUL, which is an acronym for a model for decarbonized urban living. Okay. And each word there actually means something. Okay. So the model aspect was more to do with the scalability or the fact that timber in itself can be actually made into modular components. Great. Yeah. Then the decarbonized aspect, obviously timber sequesters carbon from the atmosphere and stores it. So that's the element of decarbonized. And the living, we thought through about how best can we understand the market and introduce a product that also is aspirational from an architecture point. So not just thinking through it as an engineering element or something to do with perceptions of timber, but also thinking about it as something that can actually be equivalent to other existing products in terms of aesthetics, in terms of meeting certain spatial requirements. Great. So we had to do a bit of market study and come up with areas that actually informed the module that we came up with. So it was more of a confluence of the engineering aspect and the market in Kenya to come up with the project. So, I mean, the fact that we started that sort of as a concept, not something that's very physical, has helped us to actually build more traction to a point where we're actually thinking of doing a tower. Yeah. So it's more or less the initial steps that we did. So we have a bit of the research in-house done in terms of quality of timber, and even we worked with partners then who are very, very much involved in terms of knowledge transfer and everything. So we are just taking it from there and taking it a notch higher without the XLT tower.
And that's to say Kenyans should expect more timber, not just timber. Cross-laminated timber building, hey? So as we come to the end, as I said, I'm going to ask you guys to just share anything else that you think would be worthwhile for our viewers to hear that we haven't mentioned through this. But I'd like you to we mentioned something before this set, Zima Homes. Is it of timber? Is it... I
think actually Wakisa is better place to talk about
all right. So Zima Homes, but then I've bought half of... No, I haven't bought half of Zima Homes, but I was thinking of buying. Tell us about Zima Homes as we close. So is it of timber? What should we expect of it?
We should first expect to buy it. Everyone
expect to buy Zima Homes.
Buy Zima Homes as soon as you can because the sales are running out.
How much is it? How much is Zima Homes?
We can have that conversation. We're talking about timber. We can get into the sales aspect. I think
it would be nice to mention so that in our there's potential buyers over here.
Okay.
Yes.
I think you can also leave a link to the Zima Homes
website. Exactly. We're gonna do that. We're gonna drop that, and as I mentioned, check our social media pages. So that's the only place you're gonna get it at.
So with the Zima Homes, we haven't done it in mass timber yet.
Okay.
But it's also a first out project. This is phase 1 of Zima. There are future phases of Zima. So maybe by the time other phases happen, they'll be at a point where we've already built the demand, have like local supply of mass timber, to a point where we can actually build with timber. But even that said, with Zima in itself, there's so many sustainable strategies that have been looked into.
Okay.
I mean, the project is EDGE certifiable. EDGE is like a standard that certifies buildings according to water efficiency, energy efficiency, and embodied carbon efficiency.
Yeah.
So on the embodied energy side, what we've done is we've tried to optimize our structural members to use as less concrete as possible. So only use as much concrete as is required, and beyond that, we substitute that with different materials that actually have less concrete in them. So the percentage decrease of the carbon emissions is quite significant in that sense. So that's more or less the first step that we can do practically with what's existing before we go into the mass timber, which actually would be for the next phases.
And before I forget, you just mentioned something I'd like you to clarify. With mass timber, how much percentage of concrete do we intend to incorporate in our buildings here?
You can have a hybrid.
We're not doing away with concrete.
Yeah, you can do away with concrete, but it requires much more trial and errors, and especially for the substructure. Correct me if I'm wrong, Wekesa. So you're looking at a hybrid system where you have, number one, timber is lighter. So if your superstructure is made out of timber, you're supporting less weight because the building has less weight.
Yes,
so that means
that one.
Your requirements for the substructure is much less. And by doing so, you can only have your substructure, your substructure in concrete and steel, but less than it would be originally because you're supporting a less heavy structure, right?
Yeah.
And since you mentioned steel, do we reinforce timber? Are we going to reinforce, or are we also doing away with steel?
I mean, timber in itself has reinforcement. So the whole engineering behind it makes it strong. What I can maybe add on to that is still we have to make joinery that is made of steel, screws, bolts, plates that actually come together to piece up the whole timber element. But also there's timber that's actually purely just timber. So cross-laminated timber that's like Dowell type, where you only use timber against timber. So that's still possible as well.
So there's different ways to look at it, depending on the situation.
Yes.
But again, we are vouching for cross-laminated timber, and
very much.
we are really waiting to see the success of it.
It has the most potential in the market.
Yeah, and the way we're talking so loudly about it right now, please guys, go check out. We're going to leave down the websites. So do we have anything? I'd like to just give us this opportunity to just share anything, 1 point, 2 point of anything you'd like to mention about mass timber that we haven't mentioned throughout this session.
I think the whole health and well-being aspect. Okay. We've dwelled so much on structure and the technicalities of timber. Yeah. But there are subtleties of timber to do with health and well-being that we haven't gone into. So one being just exposure, or like visual aspects of timber. We are more drawn to nature, like the granular aspects of timber, the grains on timber and how they form. They have a way in which we gravitate towards, and psychologically, this has been proven to have positive health impacts. So besides that, I think the whole aspect of being in a healthy building also makes a lot of sense. From emissions, from materials, timber has less. So meaning you're actually healthier, more productive in that sense. And I think if we think about it now, just not about as a material, and more or less like as a solution to health and well-being, it has a lot of benefits that we can take advantage of.
All right. Yeah. Thank you, Wekesa. Joaquin?
Yeah, I think we have begun this conversation, and I obviously expect there's going to be a lot of questions, a lot of concerns. And I would like to open the door to bring up the questions to me.
Great.
And to also let you know that from August, we're going to have our prototype at our office at
Alright.
BuildX Studio.
Yeah.
So maybe you can leave my number, you can leave our website, and I would be very happy to receive a call and to welcome you to come see a cross-laminated timber prototype and to continue the conversation, mostly to answer your questions. And I'm sure there's also a lot we can learn from the professionals out there that we're speaking to at this moment.
Yeah. And it would be nice for even the university students, the construction managers. This is for your, you go and convince your clients that they should be using this material, isn't it? Yeah. So thank you so much. We can't appreciate you enough. Thank you for your time. We really appreciate you being here, and you answered the questions so perfectly.
Asante.
Asante, this is the end of it.